Hi guys, today we're going to be talking about smart pointers, and specifically in C++. So what are smart pointers and what makes them different from normal pointers? So to first review the definition of pointer, pointer essentially, it points to an address in memory. So if you have a variable x that exists in memory holding the value 10 and you want something pointing to the memory of this, you can use a pointer. This is my pointer. The data type for this is essentially pointer int. So you will write it as, so if pointer is a name, you will write it as int asterisk indicates a pointer, and this is going to be its declaration. Well, if you're going to specifically give it to x, you want to give it the address as well, so ampersand, and then write 10. Pretend this is correct, like the notation I made. Okay, so now what makes a smart pointer different is that when you dynamically allocate regular pointers in memory, so using the new keyword, you create your own piece of memory. You have to also make sure you manually delete it when you use regular pointers. Now what makes smart pointers better is that smart pointers, they automatically self-delete, well that's repetitive, self-delete as once they're out of scope. So typically, for regular pointers, if you create a pointer using the new keyword, now whatever you create with the new keyword is known as dynamic allocation. And it's you manually creating memory, so you also have to make sure that you delete that memory, right? So when we create a pointer with the new keyword, we're dynamically allocating a piece of memory for this by ourselves. And we have to also make sure we use the delete keyword to delete that same pointer. And if you forget to use the delete keyword and delete that pointer, or basically free this pointer from the object it holds, you will run into an error. So what smart pointers do is they make sure to do the deleting for you behind the scenes. So even if you create a pointer with the new keyword, a smart pointer will make sure to delete this for you, so if you forget, you're good. So let's go through the library needed to create a smart pointer. So in C, we're going to be using the memory library. Just include memory. And now we can also go through different types of pointers. So there's the shared pointer and there's the unique pointer. There's also a weak pointer. Those are the three common pointers. So essentially, to go through them, let's start with the unique pointer. A unique pointer, as the name suggests, is a pointer that points to an object, and this pointer is unique because this pointer can be the only pointer that points to this specific object. So if I have a unique pointer pointing to this, I cannot create another pointer and also point to this. That is not allowed. I'll get a crash. So I have to make sure when I create a unique pointer, first of all, it's the only thing that's pointing to it, like the memory suggests. And how it works behind memory is that once the unique pointer is out of scope, it will self-delete this piece of memory. So that's the unique pointer. So to put into words, it's the unique owner of its object. And the memory that it points to memory deallocates, or it just says it frees once the unique pointer goes out of scope. Now, on the other hand, we have something called shared pointer. And as you can guess from the name, a shared pointer is a pointer that also points to an object. However, like the name suggests, you can have another pointer also point to that object. And so how this works now is that since we have perhaps multiple pointers pointing to this object, it deletes when the last pointer pointing to the object runs out of scope. So say we have 3 shared pointers. Shared pointer 1, shared pointer 2, and shared pointer 3. Shared pointer 3, we're going to erase and say we don't need this anymore. Object will still exist in memory. And then we say shared pointer 2, we don't need you anymore. Now the object will still exist in memory. Now, since this is shared pointer is the last pointer here that points to the specific object, once this shared pointer goes out of scope, memory will also be freed. And so what a shared pointer is, it shares ownership of its object. And not just that, the memory frees when the last shared pointer goes out of scope. Okay, so I want to emphasize 2 keywords here, last and shared pointer. So it's going to be the last shared pointer, so it can't be just any pointer pointing to it, it has to be the last shared pointer going out of scope. And this is where I'll introduce the idea of weak pointer. So remember this object we had with a bunch of shared pointers pointing to it? Well, we can't have a unique pointer point to it as well, because that would then break the definition of a unique pointer being the only pointer allowed to point to its object. We can't have a shared pointer. And a regular pointer, I think this would work, I'm not really sure. However, whenever we use smart pointers in our program, we have to stick to it throughout our whole program, because we don't want to integrate and get confused and confuse the compiler. So when you choose to use smart pointers, you gotta use it throughout your program. So you can't really have a regular pointer pointed to a shared pointer. Now say, what if we do want to have something that points to this object, but isn't necessarily on the object? So when I say object, it means like when that pointer goes out of scope, it won't affect this. Or it can still point to it but this last shared pointer will still determine whether it gets deleted or not. So this is where we have the idea of weak pointers. Now a weak pointer doesn't have ownership. Doesn't have ownership. And when we say ownership, we usually mean like determines the object being freed or not. So if we have this weak pointer pointing to this object, and let's put more shared pointers. Now, if this shared pointer goes away, we have this last shared pointer. Now, if this shared pointer goes away, this object will free itself because it's the last shared pointer is the one that determines the memory existence. Whereas this weak pointer, it will also just self go once the object it points to is gone, or if you remove that pointer. So it really doesn't have ownership. So those are our 3 pointers which you kind of want to know. And they're like the most common ones used in the industry. So again, just to reiterate what's the difference between a shared pointer, you can try to take the video and pause and see if you can put it into your own words. And so what's the difference between a shared pointer? Shared pointer shares ownership of the object it points to. The object of a shared pointer goes out of scope when the last shared pointer on the object goes out of scope. Now, a unique pointer. A unique pointer, on the other hand, is the unique and sole owner of its object. You cannot have other pointers even point to its object. Its object will go out of scope when the unique pointer goes. I should read. Object will not go out of scope. Object will free itself when the unique pointer goes out of scope. So that's pretty much it.